We're doing more on algebraic expressions. What do we learned that when we have an expression like A minus B times C minus T, this is equal to, we're going to do A with times with each term on the other bracket. So this will be equal to A times C. Okay, let's just make plus here, plus like that. And then plus A times D. And then we can also times B with each term on the other bracket. So this will be plus BC, okay, plus BC plus BD. Now we're going to do this question. Let's start with question 4. The question says, what is the value of B in x plus B in the bracket times x, open bracket, x minus 1 close bracket equal to x squared plus 3x minus 4. Now, I'm going to write the question here. Your x plus B, x minus 1 equal to x squared plus 3x minus 4. Now, first, we're going to expand the expression on the left-hand side of the equal sign and simplify if possible. So we're going to do x times x, and then x times -1, and then b times x, and then b times -1. So by doing x times x, we have like x squared. X times -1, that makes -1x. Okay. Usually when it's 1, we don't write. B times x makes b times x will be bx, so I'm going to write plus bx, and then b times -1 makes -b. And this is equal to x squared plus 3x plus minus 4. Okay, now before I proceed, I need to double check on the left hand side because this is where I expand to see if our like terms to combine. Okay, now you can see that yes, there are like terms because these terms end with x, this also with x. I can combine them, I can make x as a common factor. So this expression can be written like this: x squared, and then plus, I can put x as a common factor. You can write my x there. Okay, change. And I write x over here, and then there must be -1 plus b. Okay, and then minus b equal to x squared plus 3x minus 4. Now, what this means then? It means that like terms in the other side of the equal sign must be equal. Okay, like obviously x squared will be equal to x squared. This x squared will be equal to x squared. But we care more about for this one, -1 plus b must be equal to 3. Or similarly, -b must be equal to -4 in order to find b. Now, so it means I'm going to do -1 plus b equal to 3, or I can do -b equal to -4. Now, over here, for instance, I can move the value of -1 over. So this will be b equal to 3 plus 1, and then I got the value of b, which is equal to 4. Okay. Here also, the answer must be the same, because if they're not the same, meanings are wrong. When we have two negatives like this, we can just cross the negative sign like that, and that means b equal to 4. So the same value b that we got. So b is equal to 4. All right, now we're going to do the other question, question 5. I want to move question 5 now to move my board like this, and then just through a line. And then the question 5 is somewhere here. Okay, let's do question 5 over here. We did know question 5. The question says, what is the value of g in x minus 2, open bracket, inside the bracket, and then open bracket x plus g, close bracket equal to x squared minus 6x plus 8. So we're looking for the value of g now. I'm gonna write the question here. So we have x minus 2 times x plus g, and this is equal to x squared minus 6x plus 8. Now we're going to do x times x, x times g, negative 2 times x, negative 2 times g. Okay, we're going to expand the expression on the left. This will be x squared plus gx, and then negative 2x plus minus minus 2g. Okay, we do x times x makes x squared, x times x makes x squared, x times g makes gx, negative 2 times x makes negative 2x, and negative 2 times g makes negative 2g. And then we're going to equate that to x squared minus 6x plus 8. Now, the expression on the left-hand side, let's check if they are like terms. To simplify, I think it's good habit. We can simplify because we have like terms. They're both the terms that ends with x, this and this. Okay, so I can simplify. I can write x squared plus, then I can open bracket like this, and close my brackets, and then make x there minus 2g. Okay, in the brackets here, that must be g minus 2 because I took x out as a common factor. Okay, now this simply means that g minus 2 equal to negative 6. Why? Because they're both on the other side of the equal sign, they end with x. Okay, or similarly, I can also say that negative 2 over here is equal to 8. Okay, negative 2g equal to negative 2g equal to 8. Not just negative 2, but negative 2g. So this will be what? I can say g minus 2 equal to negative 6, or I can also say negative 2g equal to 8. So let's check. If I move the negative 2 over, I can find g. G will be negative 6 plus 2. Okay, and that makes g equal to negative 4. Okay. Or let's see, we can also work it out like this. We have negative 2g, we can divide both sides by negative 2. Okay, and then we get the value of g. G will be equal to negative 4. So the answer must always be the same. Yeah. Thank you. Now we're going to do question 6. Move this over, and then let me just split my, and then now we're doing number 6. Doing number 6. Where the question says in open bracket x minus 4, close bracket, open bracket x plus k equal to x squared plus bx plus c. Now, for which of these values of k will be positive? Now, let's see. We're going to write the question first. The question is x minus 4 and then x plus k, and this is equal to x squared plus bx plus c. Now, the question says for which value of these, values of k will be positive? All right. Now we're going to expand as we used to do. Okay, we're going to do x times x times k, negative 4 times x, and negative 4 times k, and this will be x squared plus kx minus 4x. I did x squared times that, x times k, negative 4 times x, and negative 4 times k minus 4k. And this is equal to x squared plus bx plus c. Now we're going to combine the like term. So this will be x squared plus, I'm going to take x as a common factor here, minus for k equal to x squared plus bx plus c. Now in the bracket here, I'm going to write, because I take x as a common factor, so this will be k minus 4. So now I know that in order for me to find b, I must set k minus 4 equal to b there. So I say k minus 4 equal to b. Now, what are the value of k in the list, in this list here? Okay, that will make b positive. Now, because I have k minus 4, k must be a value that is more than 4. If it is, I can say 4 or more than 4. 0 doesn't really have a sign, but yes, we can just say 4 or more than 4. When I look at the list here, the value that are 4 or more than 4 is just 5. Now I can say k must be equal to 5, because if it is 5, over here, we saw 5 there, 5 minus 4 will be 1, and then 1 is positive, you see? But if it's not, let's say a number like, let's take a count example, a number like 3, for instance, for k, if we set k by 3, 3 minus 4 will be negative 1, and negative 1 is negative. But we want the answer that is positive. Okay, so k equal to 5 in the list. Now, question B says, that was question A. And then B, on the right here, B says, for which of these values of k will C be positive? Okay, then after that we expand and combine like terms in the equation, we can see that C must be the value of negative 4k. So these two will be equal. So when I set here negative 4k equal to C, then because they're both the constant term of the equation. Okay, so the fact that we can see a negative number in front of the k, this negative number, because negative 4 is negative, I know k must be negative also in order to have a positive answer. Why? Because negative times negative will make positive. Okay? But in case k is positive, then when the sign alternates, the product of sign alternates, they're all negative. Minus times plus makes minus. Plus times minus will make minus. But positive make positive. Negative and negative will make positive. So because we want a positive answer, k must be a negative. Must be negative. Therefore, I will say here, therefore, k will be something like negative 3, or k will be negative 1. Or k will be negative 1. So these are the answers. Okay. Now question C say, for what real values of k will C be positive? Okay. What real value? Now let's see. Well, now C. I'm going to write question C here. For what real value of k will C be positive? So now we already have negative 4k equal to C. So now for k to be positive, what are the real values? So meaning all the real values that are negative. Okay, so I can write it like this. This will be true if k is lesser than 0, because negative answers are given by lesser than 0 like that. So I can say k must be less than 0, because if k is lesser than 0, then the solution here with the negative 4, negative and negative, as I said, will be positive. So that's the answer. And then B says for what real values of k will be positive. Now over here we had like k minus 4. k minus 4 equal to b. Now, in order for k to be positive, so the real values will be when k is greater than, okay, I can say greater than or equal to 4, because sometimes 0 is considered as positive. So say, or if you want to be strict, let's say k must be greater than 4. Yes, k must be greater than 4. Now, k must be greater than 4, because if k is more than 4, the answer here will always be positive. Okay. Now let's take some other questions. I'm gonna put some more questions here. Okay, we have question 7. A that says expend x plus 4 over x to the power of 2. So on the right equation, x plus 4 over x to the power of 2, voilà, over x to the power of 2. So this will be, so we're going to do x plus 4 over x times x plus 4 over x. And then, as we said, we're going to do x times x and then x times 4 over x. We do that because to the power of 2 means we take the same number we times by itself, okay? So, and then we do 4 over x times x and then 4 over x times 4 over x. And then this will make x times x squared plus x times 4 over x plus 4 over x times x, and then plus 4 over x times 4 over x. Now we can simplify and combine like terms. You can see that x here numerator and that x can be cancelled out. This x with that x cancel out, and then this will be x squared plus 4 plus 4 plus 4 over x times 4 over x. So when we times fraction, we just times the numerator over, we also times by the numerator, the denominator. So that makes 16 over x squared. 16 over x squared. So we can simplify. This is the same to say x squared plus 8 plus 16 over x squared. Now that was A. B then says that was A, and then B says, given that x plus 4 over x squared equal to 14, determine the value of x squared plus 16 over x squared without solving for x. All right. We already found that x plus 4 over x squared equal to we already found that this is equal to x squared plus 8 plus 16 over x squared, 16 over x squared. Okay, but now the question says that this is equal to 14. So whatever we have here, this one is equal to 14. So I'm going to set equal to 14. So if I take the positive 8 here, I move it over the other side of the equal sign, that makes x squared plus 16 over x squared equal to 14 minus 8, which means that x squared plus 16 over x squared equal to 14 minus 8, which is equal to 6. So we have determined x squared plus 16 over x squared without finding the value of x. Thank you. So I want to take the same question because I'm going to move my board over here. Let's do the following questions. I'm going to do question 8 now. Question 8 says, answer the following question. First, expand A plus 1 over A. So A, let's say expand A plus 1 over A to the power of 2. Okay, you know this is A plus 1 over A times A plus 1 over A. Okay, because if we have like A squared, it means it's A times A. So we're going to expand by doing A times A, and then A times 1 over A, 1 over A times A, 1 over A times 1 over A. So A times A will be A squared. Okay, so maybe I'll go straight to all the steps. A times A plus A times 1 over A plus 1 over A times A plus 1 over A times 1 over A. Now A times A here makes A to the power of 2 plus A times 1 over A. All right, here it means that the denominator is 1. Okay, we need to work out, we can simplify because the fraction, we can simplify even across or horizontally. We can cross the A like this, so this is equal to just 1 plus, same also here, we can cross this A, and then we have also 1 plus 1 over A squared. So this is equal to A squared plus 2 plus 1 over A squared. Okay. Now, question B says that given that A plus 1 over A equal to 3, determine the value of A plus 1 over A to the power of 2 without solving for A. So I am going to, we already expand, okay, A plus 1 over A to the power of 2 in the previous equation, and then we got A squared plus 2 plus 1 over A. Now, the question says that this product equal to 3, okay? So it means that all here is just equal to 3. Now, if we need to find A squared plus 1 over A, we can just take these 2, okay? Move it on the other side of the equal sign, and then we will have here A squared plus 1 over A equal to 3 minus 2. So that makes A squared plus 1 over A equal to 1. Okay. Now, C say, given that A minus 1 over A equal to 3, determine the value of A plus 1 over A to the power of 2. All right. Now, I think because of space, I'm gonna move it over. Just want to take this. I'm gonna place it here. Okay. Move it a little bit there. So now we're doing question C. So A, the question says A minus 1 over A equal to 3. But now we need to find the value of A plus 1 over A to the power of 2. All right, I'm gonna write here A minus 1 over A to the power of 2 will be equal to A minus 1 over A to the power of, times A minus 1 over A. Okay, let's first expand the left-hand side, and then this will be A times A, because we do A times A here, and then A times negative 1 over A, negative 1 over A times A, and then we're going to do negative, that makes negative 1 over A times A, and then negative 1 over A times negative 1 over a. So this makes a squared minus, okay, this a and a can cancel out. Okay, here it was a bracket, excuse me. We did a times a, we got a times a, and then a times for negative 1 over a, something is missing here. So, something was missing there. Oops. So something was missing here. I need to just erase this. So we first do a times a, and then we do a times plus a, not times but minus a times 1 over a, or we can also do plus a times negative 1 over a. Let's take all the step, and then negative 1 over a times a, and then also negative 1 over a times negative 1 over a. So negative 1 over a times negative 1 over a. Now we simplify. That makes a squared plus, can cross this and that, like that. We have like a squared plus, not plus but minus now, minus 1 plus 1 over a squared. So this equal to a squared minus 2 plus 1 over a squared equal to 3. Okay, so if we move a squared, if we move that makes a squared plus 1 over a squared equal to 3 plus 2, and this is equal to 5. A squared plus 1 over a squared equal to 5. But it's not solving our problem, because the problem is to find to determine what's the value of a plus 1 over a to the power of 2, and then we cannot say this equal to 5. So what can we do in this situation? We expanded a plus 1 over a in the previous question, okay? We expanded that, and then we got it was equal to a squared plus 2 plus 1 over a squared, okay? So we also know, on the right here, we do know that a plus 1 over a to the power of 2 is equal to a squared plus 2 plus 1 over a squared, okay? Now, from the previous question, we have a squared plus 1 over a squared. So they're here a squared plus 1 over a squared. Now we can substitute, because all this a squared plus 1 over a squared is equal to 5. This sum here is equal to 5. So a squared plus 1 over a squared is also 5. So I'm going to substitute by its value here. This is equal to 5 plus 2, and then this is equal to 7. Therefore, a plus 1 over a to the power of 2 is equal to 7. Thank you. I'm gonna put more questions. More questions here. They are there. So here, question 9 says, answer the following questions. Now, question 9 says, expand 3y plus 1 over 2y to the power of 2. So we have like here 3y plus 1 over 2y to the power of 2. As we know, following this formula, okay, when you have a squared or a to the power of n means a times dot 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 a n time So when it's 2 times 1 times something twice. So 3y plus a half y to the power of 2 will be equivalent to this will be equal to 3y plus a half y to the power of 2, not to the power of 2, but times 3y plus a half y. So we're going to do 3y times 3y, 3y times a half y times 3y, a half y times a half y. And then this will be equal to 9y squared plus 3 over 2. Okay, let's do plus 3y times a half y plus a half y times 3y plus a half y times a half y. So this makes 9y squared plus this would make 3 over 2y squared. Okay. Now we can, okay, let me